Hey there, this is Mr. Alexander, and I'm going to talk about geometric sequences, which is IB subtopic 1.8. The main formula to remember here is that U sub n equals U sub 1 times the common ratio to the n minus 1 power. That's to find the nth term. To find the sum of the first n terms, you're going to use U sub 1 times 1 minus r to the n power divided by 1 minus r, the common ratio. Both of those formulas are on your formula chart, so you don't need to memorize them. Let's just jump into this right here. A geometric sequence has the form 4, 8, 16. State the common ratio. The easiest way to find the common ratio is take those first two terms and simply divide them. So the second term is 8, the first one's 4, 8 divided by 4, the common ratio is 2. It's doubling every time. If I'm going to calculate the 20th term, I'm just going to use this formula right up here. U sub 20 equals the first term, 4, times the common ratio, 2, to the n minus 1 power, so 20 minus 1. And that's just calculator work there. So 2 to the 19th power times 4 is 2,097,152. That would be the 20th term of that geometric sequence. I also want to talk about number 4 here. The first three terms of geometric sequence are -2, 6, -18, ... State the common ratio for this one. Again, easiest way to find the common ratio, r, is to just simply divide the first two terms. 6 divided by -2 is -3. Now, part B, we're supposed to calculate the sum of the first 10 terms of the sequence. So I want S sub 10. So I'm going to use this formula, U sub 1. First term is -2. 1 minus the common ratio of -3 to the nth power, so that'd be to the 10th power, divided by 1 minus -3. 1 minus -3 is simply 4. So I know whatever the numerator is, I'm going to divide by 4. Let's figure out what that numerator is. Let's do 1 minus -3, 1 minus -3 to the 10th power is going to be -59,048. I'm going to do 1 minus that multiplied by -2. 1 minus -3 to the power. 1 minus that answer. Whoops, screwed that up, didn't I? Let's try that again. 1 minus -3 to the 10th power, and then we need to multiply that by -2. My apologies, that's 118,096. Divide that thing by 4, and you've got your sum. It's 29,524. Let me show you a couple of IB problems that I've seen on previous exams. Number 7 here actually starts with an arithmetic and then goes into a geometric. The second term of an arithmetic sequence is 30. The fifth term is 90. So if I listed these things out here, 30, 90. The common difference, the easiest way to calculate it, is to simply subtract the value of the terms and then divide it by the difference of the terms themselves. So the fifth term minus the second term. So I'm doing 60 divided by 3. The common difference is just 20 here. And that makes sense because if I filled this in, then I do 50, 70, 90. The first term then is just 10. U sub 1 equals 10. And the common difference is 20. The first, second, and fifth terms of the arithmetic sequence are the first three terms of a geometric sequence. Calculate the seventh term. So I got 1, 2, 3, 4, 5, 6, 7. The first term of first, second, fifth. So that's 10, 30, 90. This is just going up by 3, so I could just simply multiply these numbers by 3 is probably the easiest way to do it. 90 times 3 is 270. Times 3 is 10. times 3 is 2,430 times 3 is 7,290. Another way to do it is to use the formula. U sub 7 equals the first term times the common ratio of 3 to the n minus 1 power, so that's to the 6th power. 3 to the 6th power is 729 times 10 is 7,290. Either way gets you the same answer. So whichever way feels the best to you. Alright, here's another geometric arithmetic question I could ask you. Only one of the following 4 sequences is arithmetic and only one of them is geometric. Which one's arithmetic, which one's geometric? The arithmetic one's pretty easy. It's the one that's going down by a constant amount, 0.05 d sub n. Now the geometric might be a little bit harder to spot. It's actually b sub n because the common ratio here is 3 halves. You'll notice that 1 times 3 halves is 3 halves. 3 halves times 3 halves is 9 over 4 times 3 halves is 27 over 8. For another geometric sequence, we've got negative 6, negative 3, negative 3 over 2, negative 3 over 4. The common ratio is just 1/2, or negative 3 divided by negative 6, which equals negative 1/2, or positive 1/2, however you want to think about that. Find the exact value of the 10th term, give your answer as a fraction. So u sub 10 is u sub 1 times 1 minus r to the nth power, which is 10. Oops. Let's try that again. Negative 6 times 1/2, which is 0.5, to the 10 minus 1 power. 0.5 to the 9th power is a crazy number, as you can see from your calculator. And we're supposed to, from the formula, multiply that by negative 6. And we're supposed to give the exact value of the term. So we don't want to write this down. We want to give them a fraction. The easiest way to get the calculator to give you a fraction is just math, enter, enter. It's going to be negative 3 over 256. Alright, I want to do one more, just because I think it's the hardest one. The hardest one here is number 6. Let's find the exact sum of this series, 1/2 plus 3/4 plus 9/8, plus 5,900. The hardest part about this is figuring out the two things r and n, because these are the two things we need to know to plug it into the formula to calculate the sum. Because the formula, we just need to know the first term, the common ratio, and the value of n. Common ratio is not too bad. It's just 3/4, which is the second term, divided by 1/2, which is the first term. And you can do that in the calculator or do it in your head. It's about 1.5. If you don't believe me, 3/4 divided by 1/2, 1.5, right there. And n is, now that one's going to be a little bit tougher. And what I recommend we do to figure out n is we just list out all these terms. I'm going to do that down here. So the first term we know is 1/2, 3/4, 9/8. To get the next one, I'm going to do 9/8 times 1.5. Now I want to keep it as a fraction. So as I'm going through here, I'm just going to convert these all into fractions. I'm going to do math, enter, enter. I'm going to make it 27 over 16. Multiply that by 1.5. Math, enter, enter. I've got 81 over 32 times 1.5. Math, enter, enter. 243 over 64. You can see this is becoming unruly, but I got to get to this last one, so I got a ways to go. I'm up to 6 terms. I'm getting closer. So times 1.5, math, enter, enter. 729 out of 128 times 1.5, math, enter, enter. I'm up to 2,187 out of 256. 6,561 divided by 512. I think it's going to be this last one. Yep. So the question is, how many terms is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. N equals 11. There. Now I can find the exact value of this sum. So I'm looking for the sum of the first 11 terms, which is the first term, which is 1/2. It's going to make it a little bit easier if I change that to a 0.5. And I can do 1 minus the common ratio of 1.5 to the 11th power, all divided by 1 minus 1.5. If you write it like this without the fractions, we can actually type this in the calculator just like this. So 1.5 times 1 minus 1.5 to the 11th power divided by 1 minus 1.5. And this is not an exact answer. The exact answer is this nasty thing, 175,099,2048. Okay, that's it. That's all I wanted to show you. Thanks for watching. Next time we'll do currency conversion and compound interest. See you for that next one.